Mineral identities. Can you identify this mineral? How would you figure out what kind of mineral it is? By its color, its shape, whether it's shiny or dull? Are there lines or striations running across the mineral? This mineral has shiny, gold, cubic crystals with striations, and, not that you can tell by looking at it here, but it smells like sulfur. What is it? In this lesson, we will discuss how to identify materials as one would in the field, that is, without using fancy lab equipment. How are minerals identified? There are a multitude of laboratory and field techniques for identifying minerals. Most are recognizable using physical properties. The most common field techniques put the observer in the shoes of a detective, whose goal it is to determine, by process of elimination, what the mineral in question is. The process of elimination usually includes observing things like color, hardness, smell, solubility in acid, streak, striations, and/or cleavage. Check out the mineral in this image. What's the mineral's color? What's its shape? Are there individual crystals? Are they shiny or dull? Are there striations or lines running across the mineral? So all of these questions can help you to identify the mineral. Color. Color may be the first feature you notice about a mineral, but color is often not as important for mineral identification. For example, quartz can be colorless, it can be purple, it can be pink, or a variety of other colors depending on the chemical impurities. Purple quartz, known as amethyst, and clear quartz are the same mineral despite being different colors. Streak. Streak is the color of the mineral's powder, which is often not the same color as the mineral itself. Many minerals, such as quartz in this figure, do not have streak. Hematite is another example of a mineral that displays a certain color in a hand sample, typically a black to steel gray or sometimes even reddish, and a different streak color, tends to be red or brown. The streak of hematite across unglazed porcelain plate is reddish brown. Luster. Luster describes the reflection of light off a mineral's surface. Mineralogists have special terms used to describe luster. One simple way to classify luster is based upon whether the mineral is metallic or non-metallic. Minerals that are opaque and shiny, such as pyrite, have a metallic luster. Minerals such as quartz have a non-metallic luster. Different types of non-metallic luster are described in this table. So the 6 main types of non-metallic luster are adamantine, which is a sparkly, earthy, which is dull or clay-like, pearly, which looks like, a pearl, resinous, which is kind of like tree sap, silky, which is soft-looking with long fibers, or vitreous, which is a glassy look. Density describes how much matter is in a certain amount of space. Density is equal to mass divided by the volume. Mass is a measure of the amount of matter in an object, so the amount of space an object takes up is described as its volume. So density is the amount of matter divided by the amount of space it takes up. The density of an object will always depend on its mass and its volume. For example, the drinking water in a glass has the same density as the water in the same volume of a swimming pool. Gold has a density of about 19 grams per centimeters cubed. Pyrite has a density of about 5 grams per centimeters cubed, and that's another way to tell pyrite from gold. Quartz is even less dense than pyrite and has a density of about 2.7 grams per centimeters cubed. The specific gravity of a substance compares its density to that of water. A substance that is more dense will have a higher specific gravity and sink in water. Hardness. Hardness is a measure of whether a mineral will scratch or can be scratched. The Mohs hardness scale, shown here, is a reference for mineral hardness. And you can see here the Mohs hardness scale is ranked from 1, which is the softest mineral or material, to 10 being the hardest mineral or material. With a Mohs scale, anyone can test an unknown mineral for its hardness. Imagine you have an unknown mineral. You find that it can scratch fluorite, but feldspar scratches it. You know then that the mineral has a hardness between 5 and 6. Note, no other mineral can scratch diamond. Cleavage and fracture. Breaking a mineral breaks its chemical bonds. Since some bonds are weaker than other bonds, each type of mineral is likely to break where the bonds between the atoms are weaker. For that reason, minerals break apart in characteristic ways. Cleavage is the tendency of a mineral to break along certain planes to make smooth surfaces. Halite breaks between the layers of sodium and chlorine to form cubes with smooth surfaces. So we say that halite has a cubic cleavage. Mica has a cleavage in one direction and forms sheets. Minerals can cleave into polygons. Magnetite forms octahedrons. Fluorite also tends to form octahedrons. One reason gemstones are so beautiful is that the cleavage planes make an attractive crystal shape with smooth faces. Fracture. Fracture is a break in a mineral that is not along the cleavage plane. Fracture is not always the same in the same material because fracture is not determined by the structure of the mineral. Minerals may have characteristic fractures. Metals usually fracture into jagged edges. If a mineral splinters like wood, it may be fibrous. Some minerals, such as quartz, form smooth, curved surfaces when they fracture. Crystaltile has a splintery fracture. Other identifying characteristics. Some minerals have other unique properties, some of which are listed here. Can you name a unique property that would allow you to instantly identify a mineral that's been described quite a bit in this concept? Hint: it's most likely found on your kitchen table or your dinner table. Some minerals have unique properties that can be used for identification, like fluorescence, which means the mineral glows under an ultraviolet or UV light. Magnetism, the mineral will be attracted to a magnet. Radioactivity, the mineral gives off radiation that can be measured with a Geiger counter. Reactivity, it'll tend to bubble when the mineral is exposed to a weak acid. Smell, some minerals give off a distinctive smell, especially something like sulfur. Or even taste, some minerals tend to taste salty. A simple lesson on how to identify minerals can be seen in this video located on YouTube. Summary. Some minerals have a unique property that makes them fairly easy to identify, such as specific gravity or salty taste. Color is not a reliable indicator of mineral type for most minerals, but streak is for certain minerals. Cleavage can be a unique and beautiful indicator of mineral type.